going to go through climbing stairs. So in this problem, we have a scenario where we are supposed to climb a certain number of stairs, and we can either climb by one step or by two steps. And we are supposed to find out what is the total number of steps, the total number of possibility solution you have to move from the initial stair to end stair. Let's say you have n equal to 2 here. Your goal is to find out how many ways do I have to move from 0 where I was to n. So here you have two possibilities. The first possibility is to take the first step and take the second step. And the second possibility is to take two steps, because you can move either one or two steps. So that's why you have two here. Now let's say you have 3. You want to go to 3. What are your solutions? You can move either 1, 1, 1, which is one possibility, or you can move 1 and 2, or you can move 2 and 1. So this makes you to have a solution of 3. Now, given this, how are we going to implement such solution? So in this problem, we are going to see two approaches, like the recursion approach and then the optimized version, the dynamic programming approach. So let us see first the recursion. How will it look like? We are going to reuse the fact that we can either move 1 or 2 steps. That means let's say I'm at position 5, right? And then I want to know how many possible solutions I can have being at position 5. You do agree with me that I can reach position 5 either by coming from position 3 or by coming from position 4, because if I'm at position 4, I have one possible way to reach here, and if I'm position 3, I have two possible way of reaching here. So I can either move from here to reach here or move from here to reach here. So knowing that, we are going to kind of create a tree which is saying that, okay, to reach position 5, I can either come from 3 or from 4, and we are going to do the same here. To reach position 3, I can either come from 1 or from 2, right? To reach position 1, I can either come from 1, no, I can either come from 0 or from -1, which doesn't exist, so we're just going to put a dash here, nothing. To hit position 2, I can either come from 0 or from 1. Okay, there we go. And to reach position 1, this one, I can either come from 0, I can either come from 0 or from minus something, so I don't count this one. This is actually a 0. It is important to circle the 0 with a different color like this. You will understand why, just a couple of minutes. So to reach position 4, I have possibility to come either from 2 or from 3. I will not continue anymore from here. I will just stop here, and you understand why I'm stopping here. So basically, you understand that you can use a recursion approach, saying that the solution at a given node to reach a given element is actually the solution coming from n-2 plus the solution coming from n-1, because you can either move 1 or 2 steps forward. And then you do agree with me that the solution, like the array that will lead you to 0, are actual valid path, because this is a valid path because you can move from 0, you can go to 1, and from 1 you can go to 3, and for 3 you can go to 5, which is a valid solution. And then here you can do the same. This one is not a solution because it doesn't lead you to something which is actually coherent. This 0, you can move from 0, 1, 2, 3, 5, which is a valid solution. You can move to 0, 2, 3, 5, which is a valid solution. So you do agree with me that the solution at 3 here, the solution here at 3 here is actually equal to 3. So this is 3. And then this solution will also be 3 because solution at 3 is 3. You can do the same. It will be the same sub array here, like the same sub tree. I mean, the solution at 2 here was 2. So this one will be 2. So the solution here will be 3 plus 2, which is actually equal to 5. And then the solution here will be this plus this, which should actually be equal to 8. But that's why I didn't continue here, because I wanted to reuse this. But from here, there's a couple of observations we can make. The first observation is that to have the solution of a given node is actually the sum of the solution minus 1 plus the solution minus 2. And if by moving down we hit 0, then it's a valid solution, we return 1. It's a valid solution that we are going to count. And then if we hit something which is negative, it's actually a non-valid solution, so we are going to cancel it. So let us look at implementation of this approach. We are going to say if the value of n is actually less than 0, that means if we find ourselves in such scenario, we return 0. If n is actually equal to 0, that means we find ourselves in this scenario, that means a valid path. In that case, we return 1. And otherwise, we just create a value which is going to be to compute the climb state of n minus 1 and climb state of n minus 2. If you want, you can just return like this. If you want, you can just return like this plus this. If you want, you can do this. It's still the same. So by doing so, you have something which is working. Why? Because you are actually respecting the condition that has been stated. You can move either 1 step or 2 steps forward. Let us wanna see what it gives. You see, it is working. Let us submit. Okay, you see now we are filling some test cases. For n equal to 44, we have a time limit exceeded. And then how can we explain that? Basically, you can see that this theory that has been computed here, the same theory will be computed here for the same operation. And then this 2 that has been computed here, it will also be recomputed here again. So you have a lot of repetition in your scenario. That is why you find yourself into time limit. And then the time complexity of such approach is actually 2 power of n. Now we are going to see a better approach which will give you in bigger of 1. And for that approach, we are going to reuse still this fact, but in a different way. In a different way, in the sense of we are going to have like an array this time, where we are going to have like element like this. And the idea will be the same. Let me just draw my array so you see. So you have index 0, index 1, index 2, index 3, index 4, index 5. So I'm ending here because that's where I'm going. We are going to use the same here. So we are going to reuse the same idea we were talking here. The fact that the solution of 5 is equal to the solution of 3 plus solution of 4. The solution of 3 is equal to solution of 1 plus solution of 2. So how are we going to reuse that? We are just going to set our base cases. Our base cases are solution of 0 is actually 0. There is no way, like if you are at 0, you are at 0. Solution of 1 is actually equal to 1. There is one way to move from 0 to 1. And solution of 2 is actually equal to 2. That is what we saw in the example. To move from 0 to 2, you can either go 1 1 or you can go 2. That's why you have 2 solutions here. But now for the order, how are we going to compute? We said solution of 3 will be equal to what? To solution of 2 plus solution of 1. Solution of 2 plus solution of 1. This will give you 3. Solution of 4 is equal to solution of 3 plus solution of 2, which will give you 5. Is that okay? Solution of 5 will be equal to solution of 4 plus solution of 3, which will actually give you 8. You see the logic? And how do we implement such approach? The implementation of such approach will be like this. So you just have your array of solution, which will have a size of n. In my array of solution, for me to put the element 2 like we saw here, because this is our base cases, but you can have n in the constant. It has been said that n will be greater or equal to 1. You can have 1. So if you have 1, you cannot set the value of 2 as your base cases. That is why you need to make extra check here to set the value of solution 2, which is equal to 2. And once you have set your base cases, now you can loop, and while looping, you just say solution of I will be equal to solution of I minus 1 plus solution of I minus 2, and at the end just return of solution of n. So this is like the dynamic programming of the solution. And then you can even have this without using a vector, since you are not you are just reusing the two last element, so you can use two variables for that. But in this scenario, I prefer to use this because it's a more general way of thinking, which can help you to re-implement the approach in different problems. So that's why I use the vector. So let us run this and see what it gives. Yeah, you see we have a solution, beat 100% of C++ solution. And then I can bet that if you are not using the vector, you have like a better memory also. So this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I will be really happy to interact with you regarding this. See you on the next video. Ciao.